Well, the Maestro Lab is a team of students and postdocs that are working on developing new applications for active materials, for adaptive structures, aerospace applications mostly, although we do some work in civil, and then also the tools needed to advance design of those kinds of concepts. The Maestro Lab maintains and runs 3 different facilities. One is our main lab where we measure temperatures, deflections, and similar outputs on adaptive structures and active material actuators that we create. So what you really need for the kind of technologies we look at is you need a place where there's an advantage to changing the shape of something, but I don't have a lot of room to install an actuator. And so the kinds of materials we look at, shape memory alloys, piezoelectrics, and other active materials, the shape memory polymers, all tend to provide a lot of motion and or a lot of force in a very compact volume.
I'm working on integrating liquid metal with shape memory alloys in order to increase the heating and cooling rates of shape memory alloy actuators. Shape memory alloys can be used to replace motors and hydraulics because motors and hydraulics are very complicated, heavy systems. SMA actuators are much less complex than comparable mechanical electrical systems.
The temperature-induced phase change in shape memory alloys allows the radiator to go from a semicircular shape like this and then to a circular shape like this when it cools. So we see that as a great way to vary the heat rejection rate in space. This project is funded by NASA Johnson, and then we work closely with Dr. Othman Benifan from NASA Glenn Research Center. They assist us all the way through the testing and development of the entire technology, and then NASA Glenn helps us with procuring and tuning the SMA material to meet the transformation temperatures and meet the certain specific requirements of what we need to complete the task.
5, good to go. The second lab is the wind tunnel facility where we will take our technologies, put them in usually a wing type platform, put them in the wind tunnel and look at response under flow, different angles of attack, look at lift and drag and pressure distributions.
What we're doing both computational and experimental analysis of a shape memory attachment to the leading edge slat of a general transport aircraft wing. The idea is that this device will reduce the noise of an aircraft as it's coming into landing and approach. The Slacko filler itself originally started off as a NASA project, and then we sort of started partnering with NASA on the computational side. They're dealing with more full scale, but they've been funding us for multiple years now. The impacts that we're hoping to have through this project are, first off, reduction of noise produced by aircraft, and we're also hoping to use this work to study other similar applications of noise reduction that can incorporate shape memory alloys.
Our project is the SMA actuated avian inspired morphing wing. This airfoil was actually taken off of an owl, and so we have the avian inspired shape, and then we have embedded actuators in the bottom skin of the wing that morphs it into a more highly cambered shape.
Supposedly owls have really good aerodynamic performance, so we tried to imitate that. And not only were we doing that, but we were putting actuators on the bottom to act as bird muscles. So as we heat this up, it will actually contract, and as it contracts, it generates an increase of camber. And that increase of camber can change your aerodynamic performance.
And then the third facility we have is our immersive mechanics visualization laboratory, the VR lab, the virtual reality lab. And that's where we will take the data from all those other experiments and our computations and visualize stress fields and how applications are performing, and also design data in higher dimensions.
And what we're working on is using emerging technology like the HTC Vive virtual reality headset or the Microsoft HoloLens, which is an augmented reality headset. And so we're trying to use these kind of immersive technologies to help better education. We actually had the SAE Aero Design team bring their plane in and put their SolidWorks model on our system, and when they were taking it apart, they were like, oh man, our battery's not going to fit the way that we thought it was. And I mean, that was a really cool understanding that comes, I mean, they've been looking at those models for a long time on a 2D computer screen, but when you bring it in to the real world using virtual reality, you can see things and just understand it from a much more intuitive perspective.
These materials are inherently multidisciplinary. They create a motion with a change in temperature. And so you can imagine we work with people like meteorologists to look at the combination of temperature and what an application might need. We work with aerodynamicists to look at how changing the shape of a structure will change the airflow. And so the goal of the Maestro Lab is to continue these interdisciplinary efforts to advance these multi-physical technologies.
I've worked in the UAV industry and a lot with machining and additive manufacturing, so it's been a really interesting experience applying that knowledge firsthand, expanding on it, and then also getting to look at it from the research academic side.
The company out of Japan known as Hartl, they actually invited both myself and Dr. Hartl to Tokyo, Japan for a conference where we were able to present some of the most recent work we've done on the Sacco filler.
The faculty are really involved here. There's a lot of funding. I've been able to go to San Diego, Chicago, and Dallas just in 1 year for conferences.
I got an opportunity to go work for NASA Goddard and work on an astronaut simulating software they were building using virtual reality.
I say be prepared to do a lot of work, but have a lot of fun. You enjoy the research. We have a lot of fun topics that we do, high tech tools that we use. It's very fun.
It's opened a lot of opportunities for me, such as being able to participate and get hands-on experience and interact with grad students.
It's a diverse team of students. We have students from many states, several countries, men and women. I mean, it's very different kinds of personalities, but all people who kind of believe in a motto that I heard once, which is, show up, work hard, and be nice. That's really what the lab is founded on.